Today we'll recreate the classic Flappy Bird video game, designing the assets in Inkscape and creating the actual game in Godot. First up, we need to create the assets for the game, so let's load up a new Inkscape document. Okay, so we'll use the page as a guideline for the assets to help us size things correctly. This means we want to give the page the same dimensions that we'll use for the game, which is 480 pixels by 800 pixels. So let's go to File, Document Properties. In here, let's change the format units to pixels, then set the width to 480 and the height to 800. And while we're at it, let's also set the display units to pixels. Then we can close out of the dialog. Next, to make it easier to manage all the assets, we'll place them into separate layers. So let's open up the Layers and Objects dialog by going to Layer, Layers and Objects. First, let's rename Layer 1 to Background. Then let's add a new layer and call it Player. Let's add another one called Pipes, then one more called Ground. Okay, now we'll work on the background, so let's make sure to select the background layer. We want the background to cover the entire page, so let's turn on snapping, and we want to make sure we have snapping to page borders turned on. Then let's grab the rectangle tool, snap to one corner of the page, then click and drag to the opposite corner. For the color of the background, we'll use a vertical linear gradient that goes from a darker blue at the top to a lighter blue at the bottom. So let's open up the Fill and Stroke dialog by going to Object, Fill and Stroke. In the Fill tab, let's click the Linear Gradient button. Now on the rectangle, let's grab the gradient node on the left side and drag it up until it snaps to the midpoint of the top edge. Then drag the one at the right to the midpoint of the bottom edge. Now back in the Fill and Stroke dialog, let's make the top color a sky blue. Then for the bottom color, let's raise the alpha channel all the way up and make it a very light blue, almost white. Next we'll add some clouds. For this, let's turn off snapping, then grab the ellipse tool. And we can create a cloud by first drawing some overlapping white ellipses. To make the cloud look better, we'll give it a flat bottom. To do this, let's first grab the Selector tool and select all the ellipses by dragging a selection box around them. Then let's turn them all into a single path by going to Path, Union. Now we can grab the Rectangle tool and create a rectangle overlapping some of the bottom of the cloud, then select both objects and go to Path, Difference. And to make it blend in better with the sky, let's give the cloud a linear gradient, then grab the Node tool and move the opaque node to the top of the cloud and the transparent one below the cloud. Okay, now to add more clouds to the sky, we can either repeat the entire process, creating a bunch of white ellipses for each cloud, or we can simply duplicate this one by selecting it and either right-clicking it and choosing Duplicate, or by using the shortcut Ctrl or Command D. Then move it somewhere else and reshape it a bit. And if we want, we can also flip it horizontally, either by clicking this button in the controls bar or by pressing the H key. Then let's create some more. Now one thing to be aware of is that we're going to make the background continuously scroll during the gameplay. And for this to work, the background image needs to be seamlessly repeatable. Therefore, if we make it so a cloud overlaps one side of the page, the part that is sticking outside the page needs to also appear inside the page on the opposite side. To do this, we can duplicate the cloud, and to move this one to the left side, we need to move it to the left by the full page width. To do this, we can come up to the cloud's X position box in the controls bar, and after the value, we can do -480. Similarly, if we have a cloud that's overlapping the left side, we can duplicate it and move it to the right by adding 480 to its X position. And don't worry about the parts of the clouds that are overlapping the page, as we'll be clipping them out later. Okay, now let's create some more clouds. And keep in mind that the bottom fifth or so of the background will be covered by the ground, so we don't need to create any clouds there. Alright, the background is finished, so next we'll work on the ground. First, let's make sure to go to the ground layer, then let's turn on snapping and grab the rectangle tool. Let's snap to the bottom left corner of the page, then drag it all the way to the page border on the right side, and a height of around 140 pixels should be good. For the rectangle's fill color, let's go with a light brown. Now let's create another rectangle that covers the entire top 30 pixels or so of this one, and let's give it a green fill color. Let's also go to the Stroke Paint tab and give it a black stroke, and in the Stroke Style tab, let's go with a stroke width of 3 pixels or so. Now, like with the background, the ground image will be scrolling during the game, so it needs to be seamlessly repeatable. At the moment though, parts of the rectangle stroke are showing inside the page on the left and right sides. To fix this, we could drag out the left and right sides of the rectangle, but another way is to go to the Stroke Style tab of the Fill and Stroke dialog, and under the Orders section, we can choose one of these three options where it draws the stroke color before the fill color. This, however, will cause the stroke to appear half as wide as before, so we can double the width to 6 pixels. Okay, now for a highlight, let's create another rectangle covering the top third of this one. Let's turn off its stroke color, and for the fill color, let's go with a lighter green. Next, we'll create some diagonal lines along the width of the green rectangles. For this, let's create a thin rectangle connecting the top and bottom corners of the darker rectangle, and then make this one an even darker green. Now let's duplicate the new rectangle, and let's set its X position to 480. Now with this rectangle still selected, let's hold down Shift and click the other one to select it as well. Then let's combine them into a single path by going to Path, Combine. Now let's open the Path Effects dialog by going to Path, Path Effects. And in the Path Effects list, let's choose Interpolate Subpaths. This allows us to create multiple copies of the rectangles with equal spacing between them. Before we add more copies, let's click the object to show the rotation and skew handles. Then let's grab the top center handle and skew the object to the right a bit. And now we can add as many copies as we want by increasing the step setting in the Path Effects dialog. Finally, let's finalize the path effect by clicking the arrow next to it and choosing Flatten. Next, we'll make the brown part look a bit better. First, let's grab the pen tool, snap somewhere on the left side of the rectangle, then create a wavy path until we get to the other side. Once we get there, let's snap to the side, then snap to the bottom right corner, then the bottom left, and finally back up to the starting node. And let's make it a darker brown than the rectangle. Now, in order for the image to be repeatable, we need to make sure the two sides of this path match up well. To do this, we can first duplicate the path and change its X position to 480. Then let's grab the node tool and let's snap the top right node of the original path to the top left node of the duplicate. We can also turn it into a smooth node and adjust the curvature. When it looks good, we can get rid of the duplicate. I'll also add in some ellipses using the same color. Finally, to give a bit of a shadow being cast from the green part, let's create a brown rectangle across here. Then in the controls bar for the selector tool, let's send the rectangle to the bottom, then bring it back up one step. Alright, next we'll work on the pipes. So let's go to the pipes layer. Now let's grab the rectangle tool and start creating a rectangle off to the side. We want the height to be at least half the height of the page, and a width of about 75 pixels should be good. For the fill color, we'll start by using the same color as the first green rectangle that we created. To do so, we can click the eyedropper icon at the bottom of the Fill tab of the Fill and Stroke dialog, then click the green rectangle. Now let's give it a black stroke, set the stroke width to 6 pixels, and make sure we still have one of the Stroke Before Fill order options chosen. Then let's go back to the Fill tab. To make it look more like a pipe, let's start by giving it a linear gradient. Let's make the color stop on the left a bit darker, and raise the alpha channel of the right stop all the way up. Now a bit to the right of the center of the gradient line, let's double click to add another stop. Then let's add another one closer to the right side and add one more between the two new ones. Let's make this one brighter. And we might need to adjust the colors of these other ones a bit as well. That looks pretty good. Alright, for the top of the pipe, let's create another rectangle that's a bit wider than this one and about 40 pixels high. And let's round the corners a bit by dragging down the circular handle at the top right. Now let's move the rectangle until the midpoint of the bottom snaps to the midpoint of the top of the other rectangle. We want this rectangle to have the same gradient as the other one, so let's give it a linear gradient, then choose the green one from the list. And let's adjust it a bit so that the highlight is a bit more to the right. Next, to add a highlight to the top of the pipe, let's grab the rectangle tool again, and let's create a rectangle that overlaps the top 10 pixels or so of this one. Let's make the corner sharp by clicking this button in the controls bar, then let's turn off the stroke color, and make the fill color the same as the lightest color of the gradient. Then let's duplicate the rounded rectangle, hold Shift and also select the new rectangle, then go to Path Intersection, leaving us with just this part. Finally, for a shadow below the top part of the pipe, let's create another rectangle here. Make it the darkest color of the gradient. Then grab the selector tool and send the rectangle down by one step. Perfect. All we need to do now is create the bird, which we'll use for the player sprite. So let's switch over to the player layer. For the bird's body, let's grab the ellipse tool and create an ellipse off to the side that's about 60 pixels in width and 50 pixels in height. Let's give it a black stroke color, and for the fill color, I'll go with the yellow. Next, for the eyes, let's turn off snapping, then create an ellipse near the right side of this one and give it a white fill. For the pupil, let's create a smaller ellipse inside this one, give it a black fill, and turn off the stroke. Then let's create an even smaller one overlapping the right side of the black one and give it a white fill. Now let's duplicate all 3 eye ellipses, make these a bit smaller, and move them to the right some. Then let's select just the 2 big white ellipses and go to Path Union. Alright, now for a shadow on the eyes, let's first duplicate the white path, turn off the stroke, and give it a light gray fill. Let's duplicate this path, make it a different color, and move it up and to the right a bit. And we want to adjust the height of this one so that there is no gray showing near the top of the eyes. Now let's hold Shift and also select the gray path, then go to Path, Difference. We also want to add a shadow from the eyes on the body. To do so, let's duplicate the white path again, turn off the stroke, and make the fill color a darker shade of the body color. For this path, we want it to have a similar size to the white path, including its stroke. To do this, let's go to Path, Dynamic Offset. Now using the Node tool, we can drag out this triangular handle until it covers most of the stroke of the other path. Then let's move the path down and to the left, send it below everything, and bring it up one step. And we might need to select all the eye shapes and move them to the right a bit so that we have a piece of the shadow path sticking out from the body. Now we can duplicate the body shape, hold Shift and also select the shadow path, then go to Path, Intersection. Okay, now for a shadow on the bottom of the body, let's grab the pen tool and create a closed path that overlaps some of the bottom of the body. Then let's duplicate the body shape, also select the new path and go to Path, Intersection. Similarly, for a highlight on the body, we can use the pen tool to create a curved path overlapping some of the top. And let's make this one a brighter color than the body. Then let's do an intersection between the path and a duplicate of the body. For an extra highlight, I'll also create an ellipse here, make it white, and rotate it a bit. Next, for a tail, we can grab the pen tool again and create a closed path over here. Let's give it a black fill and send it below everything. For the bird's wing, let's create an ellipse down near the bottom left, give it the same fill color as the body, and give it a black stroke color. Then we can turn it into a path by going to Path, Object to Path, and use the Node tool to change up the shape a bit. To give the wing a highlight, we can duplicate the wing shape, turn off the stroke, and give it the same fill color as the top highlight of the body. Now let's move it up and to the left a bit, then duplicate the wing shape again and do an intersection between it and the highlight path. Finally, for the bird's beak, let's create an ellipse over here on the right side, give it a black stroke color, and make the fill color something like red or orange. Then let's turn it into a path and reshape it a bit. And we can also give it a highlight by duplicating the shape, turning off the stroke, making the fill color a brighter shade, moving it up and to the left a bit, then doing an intersection between it and a duplicate of the beak shape. Okay, and with that, we are done creating the sprites, so now we just need to export them all as PNG images so that we can use them in Godot. And we'll start with the background, so let's switch to the background layer. First, let's select all the objects in the layer either by clicking this button in the controls bar or by using the shortcut Ctrl or Command A. Then let's group them all together by right-clicking inside one and choosing Group. We want to clip out all the parts of the group that are outside the borders of the page. To do this, let's turn on snapping, grab the rectangle tool, and create a rectangle overlapping the entire page. Now let's select the rectangle and the background group, Right-click and choose Set Clip. To export the group as a PNG image, let's open the Export dialog by going to File, Export. In either the Page tab or the Selection tab, let's check Export Selected Only down here so that it doesn't include the ground objects. Then let's choose a location to save the image, call it Background, make sure PNG is chosen as the file type, and click Save. Next, for the ground, let's start by selecting all the ground objects and grouping them together. To clip out the parts that are outside the page, let's create a rectangle that covers the parts of the group inside the page. However, we want to make sure to not clip out the top part of the stroke here. So let's resize the rectangle so it's a bit higher than the group. Then let's select them both, right-click and choose Set Clip. Alright, now to make our lives easier when using the ground image inside the game, we actually want the image to have the same dimensions as the page like the background does. To do this, we can choose the Page tab in the Export dialog, and with Export Selected Only still checked, it will make the image the same dimensions as the page, but all the empty checkerboard area here will be transparent in the image. Okay, let's save it as ground.png in the same location as the background image. Next, we'll export the pipes. During the game, we'll have the pipe scroll by in pairs with a lower pipe and an upper pipe and some spacing between them. So to make things easier, let's select all the pipe shapes and group them together. Then let's duplicate the group, flip it vertically by clicking this button in the controls bar, and move it up while holding down the Control or Command key to keep it aligned with the other one. We want there to be enough spacing between them to fit about 3.5 to 4 birds. Now let's select both pipe groups, choose the Selection tab in the Export dialog, and save it as pipes.png in the same location as the other images. Finally, we need to export the bird. However, to make it so the bird actually looks like it's flying during the game, we'll give it an animation, making its wing appear to be flapping up and down. To do this, we'll create a sprite sheet, combining all the frames of the bird's animation into a single image. And the animation will consist of 4 frames. For the first one, the wing will be parallel to the ground. For the second frame, the wing will be tilted up. For the third one, it will be parallel to the ground again, and for the fourth one, it will be tilted down. Since the wing is already parallel to the ground, we'll use all of this as both the first and third frames of the animation. To create the second frame, let's turn off snapping, then let's duplicate the entire bird, hold down the Control or Command key and move it to the right. Then let's select just the 2 wing shapes, click them to show the rotation handles, move the rotation center to near the center right of the wing, and rotate it clockwise a bit. For the third frame, let's duplicate the original bird again, then hold down Control or Command and move it to the right of the second bird. And for the fourth frame, let's duplicate again, hold Control or Command and move it to the right, select just the wing shapes, move the rotation center to the right, and rotate it counterclockwise. We're not quite done yet though, because when using a sprite sheet for an animation, Godot will assume that there is equal spacing between all the frames. It also expects that each frame's width and height are whole numbers, not decimal numbers. So what we can do is we can create some equal whole number sized rectangles as backgrounds for each frame. To do this, let's first select all the shapes of each individual frame and group them together. Then let's go to the Layers and Objects dialog, and let's create a new layer calling it Player BG. And let's click and drag the layer down until it's below the player layer. Now on the player BG layer, let's create a rectangle that's big enough to cover the entire first frame of the bird animation, and let's make it white so it's easy to see. Now let's grab the selector tool, and using the width and height boxes in the controls bar, let's round up the values to make them whole numbers. Okay, now we want to center the rectangle on the bird. To do this, with the rectangle still selected, let's hold Shift and also select the bird. Then let's open the Align and Distribute dialog by going to Object, Align and Distribute. And here, let's make sure we have last selected chosen in the relative to box, and let's align them on the vertical axis and the horizontal axis. Alright, now let's duplicate the rectangle. Hold Shift and also select the bird in the second frame, and let's only align them on the vertical axis. Then let's do the same for the third and fourth frames. Now we can turn on snapping, select the entire second frame including the background, and snap it to the right side of the first frame. Then snap the third frame to the right side of the second frame, and finally snap the fourth frame to the right side of the third one. Okay, now for exporting the sprite sheet, we want the image to have the same dimensions as all of this, but we don't want the white of the background rectangles to be visible in the image. To do this, let's select all the frames, then in the Layers and Objects dialog, let's hide the Player BG layer. Now we can go to the Export dialog, and in the Selection tab, let's export it as player.png. And with that, we are officially done creating the assets, so now we can load up Godot and get to work on creating the game. First, in the Project Manager, let's create a new project. We can call it Flappy Bird. Choose where to save the project, use mobile as the renderer, which is good for 2D games, and we won't be using source control, so we can choose none. Then let's click Create. And once the project editor comes up, let's switch over to the 2D workspace since we're creating a 2D game. Next, we'll add all the assets to the project. To do so, let's first come down here to the File System panel. The res:// here represents the main folder for our project, and it's where we should save everything that we'll use inside the project. To keep things organized, we'll place all the assets inside a subfolder. To create a subfolder, we right-click Res and go to Create New Folder, and let's call it Assets. Now with the Assets folder selected, let's open up the folder where we exported all the assets that we created in Inkscape, then select them all and click and drag them into the Assets folder in the project. We should now have all 4 of the images inside the Assets folder. Alright, now in the center of the editor we have the workspace, where we'll be able to see and edit things once we add them to the game. And here we can scroll the mouse wheel to zoom in and out, and we can press down the mouse wheel and move the mouse to pan around. We should also see a blue outline which represents the game window. At the moment though, the game window isn't using the dimensions that we want for the game. To change the dimensions, let's go up to the project menu and choose Project Settings. And here under Display and Window, let's set viewport width to 480 and viewport height to 800. And let's also set the stretch mode here to canvas items, which will keep the game centered and still looking crisp if the player resizes the window. Then we can close out of the dialog. Okay, now we're ready to start adding things to the game. To do so, we first need to come over here to the Scene panel and create a new 2D scene. This actually creates something called a node, in this case a node of type Node2D. Basically, everything we add to a Godot game, including images, sounds, and cameras, are referred to as nodes, and we use a scene as a way to organize and group together other nodes and scenes. For example, we'll later have a pipe scene which will consist of a Sprite 2D node for displaying the pipe's image or texture. It will also have two collision-shaped 2D nodes for detecting collisions between the player and each of the two pipes. It will also have a node called Score Area, which will have a collision-shaped 2D node as a child for detecting whether or not the player has passed between the pipes and should score a point. Similarly, we'll have a player scene consisting of an animated Sprite 2D node for animating the sprite sheets and a collision-shaped 2D node for detecting collisions. And finally, in one big scene called the main scene, we'll combine the pipes and player scenes along with the background, ground, and a number of other nodes. Okay, so we'll start by creating the main scene, and we'll go ahead and display the background and the ground. But first, if we take a look above the workspace here, we have a tab that indicates the scene that we're currently working on, and it says unsaved and has an asterisk next to it. This is telling us that we haven't yet saved the scene as a file in the project, so if we were to close out of the project right now, we would completely lose the scene. To save the scene, we should first give it a proper name, which we can do by double-clicking on the word Node2D in the scene panel and typing something else. Let's call it main. And to save the scene, we can go to Scene, Save Scene, or use the shortcut Control or Command S. And now we have to choose where in the project to save the scene file. As this is going to be a pretty small project, we won't worry too much about the file structure. So let's just create a new folder for all the scenes by clicking the Create a New Folder button up here, and let's call it Scenes. This also automatically takes us to the Scenes folder. We'll leave the file name as main.tscn, so let's click Save. And now the tab shows the name of the scene file. Alright, now we'll add the background image to the game. For adding images to a game in Godot, we typically use a Sprite 2D node. This means we need to add a Sprite 2D node to the main scene, and to do so, we first need to click the plus button here in the scene panel. This brings up a dialog showing all the available nodes. All nodes extend the basic node class, and for 2D games, we'll usually work with nodes that extend the Node2D subclass, which we can see by clicking the arrow next to Node2D here. There are quite a few of them, and we'll be using several throughout the tutorial. But for now, we want a Sprite 2D node. So let's select it and click Create. And now we have a Sprite 2D node that's a child of the main scene node, as we can see by the indentation to the left of it. Okay, now with the Sprite 2D node selected, if we take a look over here in the Inspector panel, we have a number of settings we can change on the node, including its texture. With the texture setting, we can add an image to the node. And an easy way to do so is to go to the File System panel and click and drag the background.png image from the Assets folder onto the texture setting box. And now we can see the image inside the workspace. What we're looking at is actually the Sprite 2D node itself, and at the moment it's centered at the top left corner of the game window, as we can see by this crosshair, which represents the node's center point. To make the background image fill up the entire game window, we need to reposition the node so that its center point is located at the center of the game window. For repositioning a node, we can either click and drag it around inside the workspace, or for more precise control over the position, we can show the transform options in the inspector and type in X and Y values for the node's position. The default is 0, 0, which is located at the top left corner of the game window. In Godot, X increases as we move to the right, and Y increases as we move down. So to center the node in the window, we need to set its position to half the game window's width and half the game window's height. So for X, let's do 240 pixels, and for Y, let's do 400 pixels. Also, notice that we have an asterisk in the main scene tab again, letting us know that the scene has some changes that we haven't saved yet. It's a good idea to get into the habit of saving your scenes often so that you don't lose progress. And I'll be doing so regularly throughout the tutorial by pressing Ctrl S. Okay, now to actually see how the game will look when the player runs it, we have a Run button here at the top right of the editor. If we click it, it will tell us that we haven't yet defined a main scene for the game. The main scene is the scene that will show up by default whenever the player first runs the game. That's exactly what our current scene called main is for, so we can click Select Current to choose it as the default scene. And now we can see the game window with the background image inside it. We can move the window around and resize it. However, it will maintain the aspect ratio of the actual game area, filling in any extra space with black. We can change this behavior in the project settings, but we'll leave it like it is for this game. Okay, we can stop the game either by closing out the window or by clicking the stop button here. Running the game also brings up the output panel down here, containing some information about our computer and any messages related to running the game. We also have some other panels like a debugger, which is helpful in case we need to debug any problems in the project. And to hide the bottom panel completely, we can click the currently selected tab again. Alright, so during the gameplay, we're going to make it so the player sprite constantly moves to the right, with the camera following them, and the pipe's background and ground will appear to be scrolling toward the left. In order for this to work with the background and ground, we basically need to have two copies of each image side by side, constantly swapping one copy to the right side of the screen as soon as it goes completely off the left side. Also, we don't want the background to scroll as fast as the ground and pipes, as that would look weird. Instead, we want the background to scroll a bit more slowly, which will give the illusion that the clouds in the background are far away from the player. This is called the parallax effect, and although it sounds like a lot of work, it's fortunately pretty easy to do in Godot because there is a special node for it. To use the node, let's click the plus button in the scene panel, and instead of scrolling through the list of nodes, we can use the search box at the top. If we start typing parallax, we should see a node called Parallax 2D. We might also see Parallax Layer and Parallax Background nodes. Parallax 2D was actually introduced in Godot 4.3 and is set to replace the other two parallax nodes, which might already be the case if you're using a newer version. Okay, so let's make sure to choose Parallax 2D, then click Create. Alright, so with a Parallax 2D node, we'll typically add a Sprite 2D node as a child of it with the texture that we want to scroll. At the moment though, I currently have the Parallax 2D node as a child of the Sprite 2D node. This is because whenever we add a node in Godot, it will add it as a child of the currently selected node. And I had the Sprite 2D node selected when I added the Parallax 2D node. To fix the order, I first want to make the Parallax 2D node a child of the main node, which I can do by clicking and dragging it onto the main node. Then I can click and drag the Sprite 2D node onto the Parallax 2D node to make it a child of the node. Okay, now everything currently looks fine in the workspace, but let's run the game. If your background texture is still centered in the window, great, you don't have to do anything. But if it looks like mine, then we obviously need to fix the positioning. The reason this is happening is that if we select the Sprite 2D node and look at its position setting in the inspector, the values were reset to 0 when we made it a child of the Parallax 2D node. We're not seeing this in the workspace because the scene hasn't been refreshed inside the workspace. To refresh it, we can go to Scene, Reload Saved Scene. And now we can see that the Sprite 2D is actually centered at the top left corner. To fix this, we just need to set its position back to 240 for X and 400 for Y. And now the game should work correctly when we run it as well. Okay, and another step we need to take is to add a camera to the scene, which will allow us to move around inside the scene. For this, we can add yet another node, and we want it to be a direct child of the main node, so let's select it first before clicking the plus button. The node we're looking for is Camera 2D. If we add one, we can now see a purple outline in the workspace, which represents the camera's viewport. It has the same dimensions as the game window, which is good, but it's currently centered at the top left corner of the window. To center the camera in the window, we can go to its offset setting in the inspector and set X to 240 and Y to 400. If we run the game again, it just looks the same as it did before, and that's because the camera isn't moving. We're eventually going to make the camera follow the player sprite as it moves, but for now we'll add some code that constantly moves the camera to the right. To add code, we have to add a script to the scene, and to do so, we can select the main node and click this button at the top right of the scene panel. For language, we'll use GDScript, which is Godot's custom programming language. The script will inherit from Node2D, which is the main node's type. For template, let's click the checkbox, and we'll use the Node default template, which provides us with some boilerplate code. Creating a built-in script will place the script directly inside the scene file. This can lead to problems later on, so I pretty much never use this option. And we'll keep the path as the default, saving it in the scenes folder. Alright, let's click Create. Doing so switches us to the script workspace, and now we can see and edit the code for the main.gdscript file. At the top of the script, we have extends Node2D. Every GDScript file is implicitly a class, and extending from another class allows the script to inherit the functions and properties of that class. A script will typically extend from the same class as the type of the node that the script is attached to. Below that, we have the ready function with a return type of void, which means the function doesn't return anything. The ready function runs when the node enters the scene tree for the first time. For the main node, this will be the case as soon as we run the game. Because of this, we should perform any initial setup stuff inside the ready function. Also, GDScript requires that every function not have an empty body, and we can use the keyword pass as a placeholder until we're ready to start adding actual code to the function. Finally, we have the process function, which also has a return type of void and has a parameter called delta of type float. The process function runs every single frame of the game, and delta tells us how much time has elapsed between the current frame and the previous frame. This is useful for ensuring that things like movements and animations in our game always work correctly regardless of any fluctuations in the frame rate. Alright, so if we would like to continuously move the camera to the right, all we need to do is increase the X value of the camera's offset by a certain amount inside the process function, and it will happen each frame. In order to do this, we need access to the Camera 2D node from inside the script. And an easy way to do so is to first make some space near the top of the script after the extends Node2D line, then click and hold on the Camera 2D node in the scene panel. If we now hold down the Control or Command key and drag the node into the empty space in the script, it will create a variable reference to the node there. The keyword var is used to define a variable, and the @onReady annotation tells Godot to not initialize the variable until after the ready function gets called. This is important because the Camera 2D node won't be available until after the main scene gets loaded. Okay, and the variable is called camera_2D, is of type camera 2D, and is set to $camera 2D, which is a direct reference to the Camera 2D node in the scene tree. So now we can use the Camera 2D variable to access the Camera 2D node, and we can actually change the variable's name to something else, like simply camera. Also, just like with scenes, we need to make sure to save any changes we make to our scripts by pressing Ctrl or Command S. Alright, so to move the camera to the right each frame, let's come back down to the process function and let's get rid of the word pass. Then let's type camera dot. And now we can see that we have access to the node's attributes and functions. We want to access the node's offset, and we want to change its x value. To move the camera to the right, we need to increase the x value, so we can do plus equals, and let's increase it by 100.0. We also want to do times delta to take the frame rate into account. So basically this will move the camera to the right by 100 pixels per second. Okay, if we run the game now, the camera does move to the right and the background scrolls, but the image doesn't repeat. To fix this, let's stop the game, then let's select the Parallax 2D node and take a look in the inspector. Under repeat here, we have a repeat size setting, which we can use to tell it when it should start repeating the texture on both the x-axis and the y-axis. A value of 0 means no repetition. This is fine for y as the game won't have any vertical scrolling, but for x we want to repeat every 480 pixels, which is of course the width of the game window. If we switch back to 2D mode, we can now see two copies of the background image side by side. And if we run the game, the background now repeats continuously. Awesome. Okay, next we'll do the same for the ground. And we can actually save ourselves some trouble by starting with a duplicate of the Parallax 2D node. But first we should give the node a more appropriate name. So let's double click it and change it to background. Now we can duplicate it by right-clicking it and choosing Duplicate. And let's change the name of this one to Ground. Duplicating a node also copies its settings and duplicates its child nodes as well. So all we need to do is select the Sprite 2D node for the ground and change its texture to the ground.png image. We can do this either by clicking and dragging the image onto the node's texture setting in the inspector, or by simply dragging it onto the node itself in the scene tree. And there we go. If we run the game now, we get a scrolling background and a scrolling ground. At the moment though, the background and ground are scrolling at the same speed. To make it look better, we want the background to scroll a bit more slowly. To do this, if we select the background node, we have a scroll scale setting in the inspector. With the default values of 1, the texture will scroll at the same speed as the camera. To make it scroll more slowly, we can use a decimal value between 0 and 1. So let's try changing x to 0.2. Doing this will also by default set y to the same value because we have the link button here turned on. But since we won't be using vertical scrolling in the game, it doesn't really matter. Okay, so we'll leave the scroll scale for the ground on 1, and if we run the game now, the background will scroll more slowly. Excellent. Alright, next we'll work on the player sprite. And because the sprite will consist of several different nodes and have its own script, we'll create a separate scene for it. To create a new scene, we can click the plus button here next to the main scene tab. This switches us to a new tab with an empty workspace, and now we need to choose a root node for the scene. We don't want to create a simple 2D scene like we did for the main scene. Instead, let's click Other Node, and the node we want is Character Body 2D. We'll typically use this node for characters in a 2D game that are user-controlled and should interact with the world. Okay, so let's create one, and let's go ahead and change the name of the node to Player. Then let's save the scene, and we'll save it inside the scenes folder using the default file name. Alright, now at the moment we have this yellow exclamation mark icon next to the node, and if we hover over it, it's warning us that the node has no shape, so it can't collide or interact with other objects. This is because in order to make it so a character body 2D, which is a type of physics body, can interact with other physics bodies, we have to define a collision shape for it. However, before we can do that, we need to add a sprite to the scene so that we'll have something visible to work with. So let's add a new node. And because the player sprite will have an animation, instead of adding a sprite 2D node, we'll add an animated sprite 2D node. Now in the inspector, if we expand animation here, we have a sprite frame setting with a box that currently says empty. Let's click the box and choose New Sprite Frames. Then let's click the box again. Doing so brings up the Sprite Frames tab on the bottom panel. This is where we create and edit animations for the sprites. We start with a default empty animation, and we can change the name of it to something else like fly. For the fly animation, we want to use the player.png sprite sheet. To load it up, we can click this grid-looking button in the animation panel toolbar, then go to Assets and double-click player.png. We then need to tell it how the frames are arranged inside the image. The frames in this sprite sheet are in a single row with 4 columns. So on the right here, we can leave horizontal on 4, but we need to change vertical to 1. And we can leave everything else as it is. And now the image should be evenly split into 4 frames. Now let's select all the frames by clicking Select All up here, then click Add 4 frames down here. And that's it. We can play the animation by clicking the play button in the toolbar. The animation will loop by default, and we can stop it from looping by toggling off this button. However, we do want the animation to loop, so let's toggle it back on. We also want to turn on this autoplay on load option so that the sprite starts animating as soon as we run the game. Also, with a default speed of 5 frames per second, the animation is a bit slow. Let's try 12. There we go. Alright, if we run the game right now, we won't see the player sprites. And that's because we haven't actually added it to the main scene. To do so, let's switch back over to the main scene tab. Now in the scene panel, let's select the root node, and to add a child scene, we click this link button next to the plus button. And here, let's choose the player scene. Now we have a player scene instance in the scene tree, and we can see the sprite in the workspace. Let's move it so it's fully inside the game window. Then let's run the game. We do see the player sprite, but only briefly, because the camera goes right past it. So let's go into the script mode, and in the process function of the main script, let's replace the code with pass, because we're going to instead make the player sprite move in a bit. If we now run the game, we can see that the player sprite's animation is working correctly. Okay, now we'll make it so the player sprite continuously moves to the right like we were doing with the camera. So let's switch over to the player scene and go to 2D mode. As I mentioned before, character body 2Ds are physics bodies, and all physics bodies require a collision shape. For this, we need to add a collision shape 2D node to the root node. So let's select the root node, then click the plus button, and let's add a collision shape 2D node. In the inspector, we can see that collision shape 2D has a shape setting. If we click the box, we get a number of shape types to choose from. For the bird's collision shape, we don't really need to worry about the tail, wings, or nose. Just the body will be fine. And because the body is elliptical, the best option for this will be a capsule shape. So let's choose New Capsule Shape 2D. Now we can see a semi-transparent blue capsule on the sprites. We can move it around using the center crosshair and resize it using the red circles. I'll also go to Transform and use the rotation setting to rotate it 90 degrees. That should work. Okay, now we're ready to start adding code to the scene. So let's select the root node, then click the Add Script button. We'll use GD script, inherit from character body 2D, and for the template, let's choose character body 2D basic movement, then click create. Using the character body 2D template provides us with some code for basic movements. We won't be needing most of it as it assumes that we're creating a platformer game, which we're not, but it's still helpful to go through the code and see how it all works. First, we have two constants, one for speed and one for jump velocity. And instead of using the normal process function, with physics bodies, we use the physics process function. Inside the function, we first have if not is on floor, velocity plus equals get gravity times delta. Is on floor is a built-in function available to physics bodies, and we use it to check whether or not the bottom of the body is currently colliding with the top of a surface. If this is not the case, it usually means the body is falling. So it then takes the velocity, which is a property of every physics body, and adds gravity to it by calling another built-in function called getGravity, which it multiplies by delta. To see and define what the getGravity function returns, we can go to Project Settings, and down here under Physics, if we click 2D, we see that the default gravity is 980, and the default gravity vector has a 0 for x and a 1 for y. So basically, adding gravity to the object's velocity every frame constantly increases the y value of its velocity, causing the object to move faster and faster down the screen. We can see this if we run the game. And even though the player's sprite touched the ground, an object needs to be a physics body in order to qualify as a surface. So the sprite falls right through the ground and goes on falling forever at an ever-increasing speed, even though we can't currently see it. To create a physics body for the floor, let's stop the game and switch over to the main scene really quick. And let's go to 2D mode. Now let's select the root node and add a new child node. For creating stationary physics bodies like walls and floors, we have the static body 2D node. So let's create one. And like with every physics body, we have to give it a collision shape. So let's add a collision shape 2D node as a child of the static body 2D node. Now because the player will be constantly moving to the right during the game, the floor surface essentially needs to have an infinite width. For this, we can go to the Collision Shape 2D shape setting in the inspector and choose New World Boundary Shape 2D. We can now see by this red line that the collision shape has an infinite width. At the moment though, the static body is located at the top of the game window. To use it as the floor, we of course want to move it down to near the top of the ground. So first, let's select the static body 2D node, and to make it easier to move, we can switch to the Move tool up here in the toolbar. Now we get arrows coming out from the right and bottom of the node. Let's grab the bottom arrow and move the node down until it's just below the top of the ground. And with that, if we now run the game, the player's sprite will stop falling as soon as it hits the floor. Perfect. Okay, now let's go back to the script for the player scene. After deciding whether or not to add gravity, it checks if it should make the player jump. To do so, it first calls the input object's isActionJustPressed function, passing in the name of a defined action. Input is a singleton provided by Godot, and it handles various types of input like key presses, mouse button clicks, and button presses on a gamepad. isActionJustPressed determines whether or not the player has just now performed a certain input action. In this case, an action defined as UIAccept. This is a built-in input action provided by Godot, and to see, modify, and create input actions, we can go back to the project settings and into the Input Map tab. And here we can add new actions, and at the moment the list of actions is empty. That's because the built-in actions are hidden by default. To show them, we can toggle on the Show Built-in Actions option. Now, among other actions, we can see the UI Accept action, which is triggered whenever the player presses either the Enter key, the KP Enter key, or the Space key. Alright, back in the code, if the player is pressing one of the UI Accept keys and the player sprite is currently on the floor, it sets the Y value of the sprite's velocity to the value of the jump velocity constant. Because the constant has a negative value, it causes the sprite to move up. Then, during the next frame, the sprite will be above the floor, so gravity will start pulling it back down again. If we run the game, whenever the player's sprite is on the floor, we can press, for example, the space key to make it jump. Okay, after that, the script creates a variable called direction and sets it using the input object's getAccess function, passing in two defined actions called UI left and UI right. This basically just determines if the player is trying to move left or right. And if so, it sets the velocity's x value using direction times the speed constant. Otherwise, it sets the x value using the built-in move toward function, basically reducing the value down to 0 over several frames so that the sprite comes to a smooth stop. So if we run the game, we can use, for example, the left and right arrow keys to move the player sprite. And finally, we have a call to move and slide, which is a built-in function that takes care of actually moving the sprite and dealing with collisions between it and other physics bodies. Alright, so as I mentioned before, a lot of this code doesn't apply to our game since we're not creating a platformer. Essentially, all we need to do is make the player sprite constantly move toward the right and have gravity pull it toward the ground. And we'll only have a single input action, allowing the player to move up, kind of like a jump but in midair. Okay, so to start, let's get rid of all the code in the physics process function and replace it with a pass for now. For the constants, let's get rid of these two, and let's create a new one with const h_speed for the horizontal speed. We can explicitly set its type to float by typing :float. And let's set it to 100.0. Next, for moving the sprite up, let's do const v_speed :float equals 350.0. And instead of using the built-in getGravity function, we'll create a constant for the gravity. So for this, let's do const gravity :float equals 1000.0. Okay, now because we want the sprite to move to the right at a constant speed, we only need to set the x value of its velocity at the start of the game. As we learned when writing the script for the main scene, every scene has a ready function that we can use for explicitly setting up some things when the scene first gets added to the game. We don't currently have a ready function in the player script though, so we'll need to create one. To do so easily, we can start typing func_ready and it should bring up a suggestion box. If we double-click the first one, it will finish creating the function for us. Alright, now inside the function, let's set velocity.x to the h-speed constant. If we try this right now though, it won't actually work. And that's because we need to go to the physics process function and call the move and slide function. And now the sprite will move to the right. However, at the moment, the camera doesn't follow the sprite. To fix this, let's go to the main scene and switch to 2D mode. In the scene panel, let's grab the camera 2D node and drag it onto the player node to make it a child of the player. And now if we run the game, the camera will follow the player and we have our scrolling ground and background back. However, if we stop the game and switch over to the debugger panel, we can see in the errors tab that we have 3 messages. The 2 yellow ones are just warnings and we don't need to worry about them right now. But the red one here is an error, telling us that in the ready function of the main.gd script, it's not able to find a node called camera2D. If we click on the message, it takes us to the line in the script that contains the error. The reason it's not finding the camera 2D node is that the node is now a child of the player scene instance. So the $sign camera 2D here is no longer correctly referencing the node. The correct reference is now $sign player / camera 2D. But in any case, we don't actually need a reference to the camera at the moment, so we can go ahead and delete the line. And now if we run the game, we should only get the 2 warnings, which we'll fix later. Alright, next we'll make it so gravity constantly pulls the player sprite toward the ground, and we'll let the player move the sprite up a bit, either by pressing the space key or by clicking inside the game window. So let's go back to the player script. To apply gravity to the sprite, let's go to the physics process function, and before calling move and slide, let's first make sure the sprite isn't touching the floor by typing if not is on floor. And if so, let's do velocity.y plus equals gravity times delta. Now the player sprite will be pulled down until it hits the ground. A problem we have right now though is that the camera follows the sprite down as well, so we can now see an empty area below the ground. What we want to do instead is prevent the camera from moving vertically at all. To do this, in the scene panel for the main scene, let's click on the camera 2D node, and in the inspector under limit, we can provide some values for limiting the camera's movement. To prevent it from moving up, we can set top to -400, and to prevent it from moving down, we can set bottom to 400. Let's give it a try. Awesome. Okay, now to make it so the player can either press the space key or click inside the window to move their sprite up, we'll need to create a custom input action. As we saw before, we can do this by going to the project settings and into the input map tab. And let's go ahead and hide the built-in actions as we won't be needing them. To add a new action, we type a name for the action in the box here. This is actually going to be the only action we'll use in the game, and we'll use it for starting the game as well. So we can simply call it action. Then let's click the add button here, and now we can see the action in the list. To add an input event to the action, we click the plus button here on the right. And here we can either search for an event, or we can use this box that says listening for inputs. For example, if we click the box, it now says left mouse button, and we have to add each input event separately. So let's click OK, then let's click the plus button again. Now we can press the space key, then click OK again. And that's it. We can now close out of the dialog and start using the action in the script. To do so, back in the physics process function of the player script, let's first get out of the is on floor block by pressing enter to go down a line, then backspace once to remove the indentation. Now let's type if input.isAction. We have 2 options for checking if the player is trying to perform an action: is action just pressed and is action pressed. We use is action pressed if we want to keep performing an action as long as the player is, for example, holding down the space key. And we use is action just pressed to only perform the action when the player first presses the key. This is what we want for Flappy Bird, so let's choose is action just pressed. And we have to pass in the name of the action we want to check for, so let's do quote action. Then inside the if block, we can move the sprite up by doing velocity.y equals -v speed. Okay, let's give it a try. Now we can make the sprite move up either by clicking inside the game or pressing the space key. Very cool. At the moment though, we're able to fly above the top of the window. To fix this, let's go to 2D mode for the main scene. Like with the floor, we need to add a static body near the top of the game window to act as a ceiling. And we can start by duplicating the floor's static body 2D node. But first, let's change the name of it to something like boundary L, since it will be for the lower boundary. Now let's duplicate it and change the name of this one to boundary U. Then using the move tool, let's move this one up to near the top of the game window. Alright, and if we look closely, we can see a little arrow pointing up from the node's center. This is actually coming from the Collision Shape 2D node, and it's the World Boundary Shape 2D's normal vector. Godot uses the shape's normal vector to determine in which direction other physics bodies can collide with the shape. With the vector facing up, things can only collide with the shape if they're coming from above the shape, not below it. This is what we want for the floor, but we want the opposite for the ceiling. So to fix it, all we need to do is go under Transform in the inspector and set rotation to 180 degrees. And now the player sprite won't be able to go above the top of the window. Okay, now to make all of this look a bit better, we can make the sprite tilt a bit as it moves up and down. To do this, let's go back to the player script, and let's first create a new constant up here by typing const tilt_angle : float equals 0.05. Now, just above the call to move and slide in physics process, we can set the scene's rotation using either the rotation property for radians or the rotation degrees property for degrees. Let's go with rotation degrees. And let's set it to velocity.y times tilt angle. With this, the player sprite will tilt up when its y velocity increases and tilt down when it decreases. If we give it a try right now though, it doesn't work as expected. And the reason is that the camera is a child of the player, so it rotates along with the player. To fix this, instead of rotating the entire player's scene, we only need to rotate its animated sprite 2D node. To do so, we first need to get a reference to the node, so near the top of the player script and with the player scene tab selected, let's click and hold on the animated sprite 2D node in the scene panel, then hold down Ctrl or Command and drag it into the script. And we can change the name of the variable to simply sprite. Okay, now back in physics process, we can add sprite dot before rotation degrees to only set the rotation of the animated sprite 2D node. Let's see if it works. Perfect. Alright, now that the player sprite works pretty well, we'll next add some pipes to the game. To do so, let's first go to 2D mode and create a new scene. For the root node, let's click Other Node, and this time we'll use an Area 2D node. With an Area 2D node, we can add multiple collision shapes as children of the node and detect when the collision shapes of other objects have entered or exited the area's collision shapes. And we can decide what actions to perform when this happens. Okay, so let's create one, then let's change the name to Pipes and save the scene in the Scenes folder. Next, as a child of the scene, let's first add a Sprite 2D node. For the Sprite 2D's texture, we of course want to use the pipes.png image. And now we need to create some collision shapes for the pipes. To do so, we'll create 2 collision shapes for each pipe, one for the long part and one for the wider part. So first, let's make sure to select the root node, then let's add a collision shape 2D. For the shape setting, let's go with New Rectangle Shape 2D, then resize and reposition it to fit the long part of the top pipe. Now we can duplicate the collision shape 2D node and make this one fit the top part of the pipe. Resizing this one, however, also resizes the other one. The reason this happens is that both nodes are actually using the same rectangle shape 2D object. So let's press Ctrl or Command Z until the shape is back to its original size. And now with the duplicate node selected, let's click the arrow next to its shape setting and choose Make Unique. This will make it a separate object from the other node's rectangle shape 2D object. And now we're free to resize it. Okay, now for the bottom pipe, we can start by duplicating both collision shape 2D nodes. To do so, we can hold down Control or Command and click the other node to also select it, then right-click and choose Duplicate. And because we don't need to change the shapes of the rectangle shaped 2D objects, we don't have to worry about making them unique. We can just move the nodes into place on the bottom pipe. Okay, now before we deal with the collisions and stuff, we'll get the pipe spawning and scrolling across the game. To do so, let's save the pipe scene, then switch over to the main scene. First, let's instantiate an instance of the pipe scene by selecting the main scene's root node, clicking the link button up here, and choosing pipes. So what we'll do with the pipes is, every couple of seconds or so, we'll spawn an instance of them a bit off the right side of the game window, and we'll also randomize their Y positions a bit. And because the camera is constantly moving to the right, we don't even have to move the pipes manually. We can just set their position and they will scroll to the left automatically. We can see this if we run the game right now. Alright, so to instantiate a set of pipes after a certain amount of time, we need a timer of some kind. And if we select the root node and add a new node, we actually have a node for this called timer. So let's create one. And because we'll have a couple different timers in the main scene, let's call this one pipe timer. Okay, now in the inspector for the timer node, one setting we have is wait time. This is how many seconds to wait before performing a particular action, such as spawning a set of pipes. Let's go with 2 seconds. Next we have one shot. If we turn this on, the timer will stop running after the first wait time finishes. Otherwise, it will start over from 0 and wait again. We want the pipes to continuously spawn every 2 seconds, not just once. So we'll leave one shot turned off. And we have auto start. When this is turned off, we have to manually start the timer using code. Otherwise, it will start automatically. We're eventually going to make it so the pipes only start spawning after the first time the player clicks the screen, but for now, we want the timer to start automatically. So let's turn on auto start. Okay, now to tell it what should happen when the wait time finishes, we need to go to the Node tab here next to the Inspector tab, and in Signals, we have a list of signals that are emitted from the selected node when a particular event occurs. When a timer's wait time runs out, it emits the timeout signal. So what we want to do is listen for the signal, and once we receive it, we'll run some code for spawning a set of pipes. To do so, if we double-click timeout, it brings up a dialog that lets us connect the signal to a receiver function inside a script. By default, we have the main scene script selected, and the function will be called onPipeTimerTimeout. That all looks pretty good to me, so let's click connect. Doing so creates the onPipeTimerTimeout function inside the main script, and it currently doesn't do anything. To make it so the function can spawn a set of pipes, we first need a reference to the actual pipe scene from inside the main script. Creating a reference to a scene is similar to creating one for a node. First, let's make some space near the top of the main script. Then let's open up the Scenes folder in the File System panel. Now let's click and hold on the pipes.tscn file, then hold down Control or Command and drag it into the script. This creates a constant called pipes and sets it to a call to the built-in preload function, passing in the location of the pipe scene file. The preload function essentially provides a reference to the given scene, allowing us to create instances of it inside the script. Okay, now for actually spawning the pipes, we'll do so inside a custom function. So let's come down here below the onPipeTimerTimeout function, and let's create a new one by typing func spawn_pipes, and it will have a return type of void. To create an instance of the pipe scene, we can create a variable by typing var new_pipes, then set it to the pipes constant, calling its instantiate function. After that, we can set the instance's position by typing newPipes.position equals. This requires a vector2 object, so let's create one by typing vector2. Now for x, because the camera is constantly moving to the right, we can't just simply pass in a value that's larger than the game window width. Instead, we need to take into account the camera's global position inside the game. To do so, we first need to get a reference to the camera 2D node, so let's come up to the top of the script and make some space. Then let's click and hold on the camera 2D node, hold down Control or Command and drag it into the script. And let's change the variable's name to camera. Now back in spawn pipes, we can set the vector2's x value by first calling camera.getScreenCenterPosition. This returns a vector2 with the center position of the screen relative to the camera. We only want the x value of the position, so let's add .x. And to place the pipes completely off the right side of the window, we need to add a bit more than half the window width to the value. I found that doing plus 300 works pretty well. Okay, now for the y value of the pipe's position, we're eventually going to randomize it, but for now, let's just do 400 to place it at the center. Alright, after that, we need to actually add the pipes to the scene. To do so, we call the built-in addChild function and pass in new pipes. Finally, we need to call the spawnPipes function inside the onPipeTimerTimeout function. Then let's give it a try. The first pipes we see are actually the pipes that we instantiated earlier, and we'll get rid of them soon. But now every 2 seconds, we get a new set of pipes scrolling across the screen. Okay, now for generating a random y value for each pipe's instance position, I found that using something between 220 and 440 works well. Okay, so let's first create a constant for this at the top of the script by typing const pipe _y_range vector2 equals vector2 220.0 comma 440.0. And let's actually also create a constant for the pipe's x offset by doing const pipe _x_offset float equals 300.0. Then in spawn pipes, before setting the position, let's do var y pause equals and call the randf_range function. As arguments for the function, let's do pipe y range.x, pipe y range.y. randf_range is a built-in function that generates a random float between two provided floats. And now when setting the position of new pipes, instead of using plus 300 for the x value, we can use plus pipe x offset. And instead of using 400 for y, we can use y pause. And let's go ahead and get rid of the pipes instance in the scene panel by right-clicking it and choosing delete. Then let's run the game. Awesome. At the moment though, the pipes are being drawn in front of the ground. It would probably look better if they appeared behind the ground. One way that Godot determines the order in which to draw objects in the game is to go by the order of the nodes in the scene tree. Nodes that are further down the tree get drawn later than nodes that are higher up the tree, so the lower nodes appear in front of the higher nodes on the screen. And whenever we add a new pipes instance to the scene, it gets placed at the bottom of the tree, so it appears in front of everything else, including the background, ground, and player. To make the pipes appear between the background and ground, we can create a node between the background and ground nodes and add the pipes as children to the node. To do so, let's first select the root node, then add a new child node. And we can make this one a simple node 2D. Let's change the name of it to pipe container. Then let's drag it up the tree so that it's right between the background and ground nodes, making sure we don't accidentally make it a child of one of the nodes. Alright, now like with the camera, we need a reference to the node inside the main script. So let's click and hold on it, then hold down Control or Command and drag it into the script. Then we just need to come down to spawn pipes And when calling addChild here, we can instead do pipeContainer.addChild to add the pipes as a child of the pipeContainer node. And now the pipes will appear between the background and ground images. Alright, now another problem we have is that even when a set of pipes scrolls off the left side of the screen, it doesn't get removed. It still exists inside the game, unnecessarily using up resources. We can see this while the game is running if we come over to the scene tree and choose Remote, then show the main contents, then the pipe container contents. And here we can see that the pipe scene instances, which are area 2Ds, are continuously being added to the game but never getting removed. To fix this, let's stop the game and we'll write some code that removes a pipe's instance whenever it goes completely off the left side of the screen. To do this, let's first create a new function down here by typing func check_pipes with a return type of void. We'll call this function every frame using the process function. So all we need to do is first check if the pipe container node has any children. If it does, its first child will be the one that is closest to the left side of the screen. Therefore, we just need to check if the first child has gone completely off the left side of the screen, and if so, we'll remove it from the game. Okay, so to check if the pipe container node has any children, we can do if pipeContainer.getChildCount is greater than 0. And if so, let's create a variable to reference the first child by doing var first_pipes equals pipeContainer.getChild, passing in a 0. To check if the pipes have gone off the left side of the screen, we can do if firstPipes.position.x is less than camera.getScreenCenterPosition.x minus pipeX offset. And if so, to remove the pipes from the game, we call firstPipes.queueFree. QFree is a function that we can call on any node and which essentially removes the node from the game as soon as possible. Okay, now we just need to call checkPipes in the process function, and if we now run the game and check out the remote scene tree doc, we can see in pipe container that it now removes the first child whenever it goes off the left side of the screen. Okay, so with all of that taken care of, we'll next make it so the player dies if they touch one of the pipes. To do so, let's go to the player script. Alright, so when the player dies, we'll stop the sprite from moving to the right, and we also won't allow the player to move the sprite up. So first, at the top of the script, let's create a variable for keeping track of whether or not the player is dead by typing var dead. We'll give it a type of bool for boolean and set it to false by default. Next, we'll create a function that we'll call whenever the player should die. So down here, let's type func die with a return type of void. Now if the player is already dead, we don't need to do anything. So let's type if dead return. This will prevent any of the following code from running. Okay, so below the if block, let's start by setting dead to true. Then to stop the forward movement, let's do velocity.x equals 0. And let's also set velocity.y to 0 in case the sprite is currently moving up. Now we also want to stop the sprite's animation. To do this, we can call sprite.stop. Okay, and to stop the player from moving the sprite up if they're dead, let's come up to the physics process function. In the if input.isAction just press statement here, let's add to the condition by typing and not dead. So now the player has to be performing the input action and not be dead in order to move the sprite up. Alright, now for calling the die function, let's save the script, then let's go to the pipe scene. We'll need to add a script to the scene, so with the root node selected, let's add one. We can leave everything as it is and click Create. And we actually won't be needing the ready function or the process function, so we can remove everything except the extends area 2D line. Okay, now if we click the root node again and take a look in the node tab next to the inspector, we have some signals that get emitted whenever another Area 2D or a physics body enters or exits the pipe's area. When the player scene, which is a physics body, enters the area, it will trigger a body entered event. So let's double-click the body entered signal. This will connect the signal to a receiver function called onBodyEntered in the pipe scene script, which sounds about right, so let's click connect. We now have an onBodyEntered function inside the pipe script. This function has a parameter called body with a type of node2D. This will represent the object that has entered the area. Now, a problem with this is that the function will be called whenever any physics body enters the area, including not only the player, but also the upper and lower boundaries that we created. Therefore, we first want to check if the body is indeed the player. To do this, we need to go back to the player script really quick and define an explicit class for the script. To do so, near the top of the script, we can type class_name and call the class player. If we now save the script and go back to the pipe script, inside the onBodyEntered function, we can check if body is player, and if so, we can call body.die. And with that, if we run the game and touch a pipe, we stop moving to the right and fall straight to the ground. We also can't move up anymore. Okay, now just for fun, we'll also make it so the player dies if they touch the floor or the ceiling. To do so, let's go back to the player script. In the physics process function between the two if statements, we can check if the player is touching the floor by typing if is on floor. And for the ceiling, we can do or is on ceiling. If either of these conditions is true, we can simply call the die function. And now touching the floor or the ceiling will cause the player to die. Alright, next we'll make it so the player can score some points as they fly between each set of pipes. To do this, let's go to 2D mode for the pipe scene. So what we'll do is we'll add another Area 2D as a child of the scene, which we'll place a bit off to the right of the pipes. And if the player enters into the area, we'll emit a signal, which the main scene will receive and increase the player's score. Okay, so first, let's make sure we have the root node selected for the pipe scene, then let's add an Area 2D node. And let's call it Score Area. Now let's move it to the right of the pipes. We want the score area to be just far enough to the right that the player sprite will have to pass completely between the pipes before they enter it. Alright, and Area 2Ds require a collision shape, so let's add a collision shape 2D node as a child of it. For the shape, we can choose New Rectangle Shape 2D and create a rectangle with a narrow width and a large enough height to account for the area between the pipes. Okay, now let's save the scene and go into the pipe script. Like with the pipe's area, we need to connect up a receiver function for when a body enters the score area. So let's select the score area node, go to the Node tab, and double-click the body entered signal. Everything looks good in here, so let's click Connect. Alright, now we could create a function in the main scene for increasing the score and call it from inside this receiver function, similar to the way we're calling the player's die function in this one. However, to show you another way, we'll instead emit a custom signal and receive it inside the main scene. To do this, we first need to define the signal near the top of the script by typing signal, and let's call it score_points. And now in onScoreAreaBodyEntered, even though the player will likely be the only physics body that can go through the score area, we can still make sure by typing if body is player. And if so, we can emit the signal by calling scorePoint.emit. Okay, now to receive the signal, let's save the script, then go to the main script. First, we need to create a variable for the score. So up here, let's type var score:int and set it to 0 by default. Next, for increasing the score, let's come down here and create a new function by typing func score_point with a return type of void. And in here, let's do score plus equals 1. We're eventually going to display the score at the top center of the game window, but for now we can print it as a message in the output panel. To do this, we can call the built-in print function and pass in score. Okay, now we need to use this function as a receiver function for the score point signal of each set of pipes that we add to the game. To do this, let's go to the spawn pipes function. Sometime after instantiating the new pipes, we can do new pipes.scorePoint.connect and pass in score point. With this, we're calling the connect function on the new pipe score point signal and passing in a reference to the score point function in the main script. And now if we run the game and keep an eye on the output panel, it will increase and print the score each time we pass through a set of pipes. Okay, now that we know the score works, instead of printing it, we'll display it in the game window. To do so, let's first go to 2D mode for the main scene, then let's select the root node and add a new child node. The node we're looking for is canvas layer. A canvas layer is great for things like UI and HUD elements, as anything we place inside the layer will stay in one position in the game window and will appear above everything else in the game. So let's create one. Although we can't actually see it, a canvas layer node fills in the entire game window. Okay, now for displaying the score, we need to add a node as a child of the canvas layer. This time we're looking for a label node, which we can use for displaying text. Let's create one and change the name to score label. Now if we go to the inspector for the score label, we have a text setting. Let's type a 0 inside the box. By default, the text is way too small, and the label is right up against the top left corner of the window, or to be more precise, the top left corner of the canvas layer. To reposition it, up here in the toolbar, we have this Anchor Presets button. And if we click it, we can choose where to position the node inside the canvas layer. Let's choose the top center by clicking this button. Now for changing the size of the text, we can first go to Label Settings here in the inspector, click the arrow next to it, and choose New Label Settings. If we then click the Label Settings box itself, we get some more options for editing the text. If we show the font options, we can change the size of the text here. Let's go with something pretty big like 64 pixels. We can also change the color if we want, and we can add an outline to the text. Let's give it a black outline and try a size of 10. That looks pretty good. Alright, and here we can set the horizontal and vertical alignment of the text inside the label. Let's go with center for both. If we now run the game, we can see the score label, which stays in place at the top center of the window. Okay, now to make the score label actually display the score, let's stop the game and go back to the script. We first need to get a reference to the score label node, so let's grab the node, then hold Ctrl or Command and drag it into the script. All we need to do now is go to the score point function, and instead of printing the score, we can do scoreLabel.text equals score. A label's text property, however, is looking for a string, not an integer. So we can pass in the score variable as an argument to the built-in str function, which will convert the value to a string. And now the score label will update as the score increases. Okay, so all we have left to do is, instead of starting the game immediately when the player runs it, we'll add some text on the screen telling the player to click the screen in order to start the game. We'll also bring the same text back up after the player dies. Okay, so to start, we need to create another label, which we'll also add as a child of the canvas layer. So let's go to 2D mode, then let's select the canvas layer node and add another label node to it. And let's change the name to Start Label. For the anchor of this one, let's go with the center of the screen. And for the text, let's type click to play on 3 separate lines. Let's create some new label settings for it, and we'll give it the same look as the score label. So for the font size, let's go with 64, and for the outline, let's make it black and set the size to 10. And let's also center align the text both horizontally and vertically. Alright, so what we'll do is, when the player first runs the game, we'll have the start label showing and the player sprite animating and moving to the right. However, the sprite won't yet be affected by gravity, and we won't start spawning the pipes until the player actually starts the game. Okay, so let's save the scene, then go into the script. First, we need to create a variable to keep track of whether or not the game is currently running. So up here, let's type var running :bool equals false. Next, in the process function, we only need to call check pipes if the game is running. So above the line, let's type if running : To put the check pipes line inside the if block, we can click in front of the line and press the tab key. Now if the game isn't running, we'll check if the player is performing the input action that we created, and if so, we'll start the game. So right below the if block, let's do elif input.isAction just pressed (action). Elif, which is short for else if, allows us to check for another condition if the previous one is false. Okay, and there are a few things we need to do when starting the game, so we'll create a function for it called start_game. Now let's create the function down here by typing func start_game with a return type of void. And here let's first set running to true. We also want to hide the start label. This means we'll need a reference to the label, so let's create one up here. Then back in start game, we can hide it by calling startLabel.hide. Now we also want to wait until start game is called before we start the pipe timer. At the moment though, if we select the pipe timer node and look in the inspector, we have auto start enabled, which starts the timer straight away. So let's turn this off. Then let's create a reference to the pipe timer node inside the script. And now back in start game, we can start the timer by calling pipetimer.start. Alright, now we need to do some things inside the player script. So let's save the main script, then head over to the player script. First, we'll need to keep track of whether or not the player sprite is active. We'll activate the sprite when the player starts the game, which will then cause the sprite to be affected by gravity. So for this, let's do var active :bool equals false. Next, in physics process, the only thing we need to do if the sprite is not active is call move and slide, since we still want the sprite to move to the right. So at the very top of the method, let's do if active : Now we need to move all the lines except the move and slide call into the if block. To do this easily, we can select all the lines and press the tab key. Okay, now for activating the sprite, let's come down here and create a new function by typing func activate with the return type of void. And here let's set active to true. And just for fun, let's also move the sprite up by typing velocity.y equals -v speed. All we need to do now is call the activate function from inside the main script start game function. So let's save the player script, then go to the main script. First, we need to create a reference to the player scene instance inside the script. Then in start game, we can call player.activate. And that's it. If we now run the game, we'll see the start label with the player sprite moving to the right but not falling and with no pipes. And if we click the screen or press the space key, the game will start. Awesome. Okay, so finally we'll make it so a couple seconds after the player dies, the screen will fade to black, then the game will reset and the player will have to click the screen again to restart the game. To do this, we'll first need to let the main scene know when the player dies, and we can do so by emitting a signal. So let's go to the player script, and let's first create a signal up here by typing signal died. Then in the die function, we can emit the signal by calling died.emit. Now before we deal with receiving the signal, let's save the script and switch over to 2D mode for the main scene. To get everything working, we'll need to add a couple new nodes to the scene. One for a timer to wait a couple seconds before fading the screen to black, and one for fading the screen to black. So first, for the timer, let's make sure we have the root node selected, then add a timer node to it. And let's call it Game Over Timer. In the inspector, let's set wait time to 2. We only want the timer to run once, so let's turn on one shot. And we don't want it to start automatically, so we'll leave auto start turned off. Okay, now for the node to black out the screen, we'll place it inside the canvas layer so that it's above everything else. So with the canvas layer node selected, let's add a child node. This time we'll use a color rect node. As the name suggests, this node allows us to create a colored rectangle. So let's add the node and let's change the name to blackout. To make the rectangle fill up the entire game window, we can go to the anchor presets and choose the full rect option at the bottom right. And to change the color of it, we have the color setting in the inspector. Let's set it to black, and we want it to start out completely transparent, so let's set the alpha channel to 0. Now at the moment, even though we can't see the color rect in the workspace, it's still covering everything else. And now we can't select any of the other nodes in the workspace. To fix this, we have a lock button here in the toolbar. If we click it, it will lock the current node, which will prevent us from selecting or moving the node in the workspace, so now we're able to select the other nodes. Alright, let's save the scene, then go to the main script. And let's go ahead and create a reference for both the Game Over Timer node and the Blackout node. Okay, next we'll connect up a receiver function to the player scene's died signal. To do this, if we select the player scene instance in the scene panel and go to the Node tab, we can see the died signal in here. So let's double click it. This will connect the signal to a function in the main script called onPlayerDied. That sounds good, so let's click connect. One thing we want to do in the onPlayerDied function is to stop spawning the pipes. To do so, we can call pipetimer.stop. And the other thing we want to do is start the game over timer by calling gameovertimer.start. Okay, now when the game over timer finishes running, we'll fade the screen to black, reset the game, then fade it back in. To do all of this, we first need to select the game over timer node, then in the Node tab, let's connect up a receiver function for the timeout signal. The first thing we'll do in the receiver function is fade in the blackout node, which will black out the screen. After that, we'll reset the game, and finally we'll fade out the blackout node, showing the screen again. In order to do this, we'll essentially need to animate the node's transparency. And for this, we can use something called a tween, which allows us to animate one or more of a node's properties. To create a tween, we need a tween object. And for this, we can create a variable by typing var tween and give it a type of tween. Then let's set it to getTree.createTween. The built-in getTree function gets the scene tree, and the createTween function creates a tween object inside the tree. Okay, now to use the tween to animate a node's property, we can call tween.tweenProperty. For the arguments, we need to pass in the node to modify, so blackout. After that, we need to pass in a string for the property that we want to animate. We want to animate the alpha channel of the node's color. And if we take a look at the inspector for the blackout node and hover over the color setting, we get a pop-up telling us that the property name that corresponds to the setting is color with a lowercase c. So for the second argument of tween property, let's type quotes color, and we can choose just the alpha channel by adding :A after the word color. Next, we need to tell it what the final value of the property should be. The color's alpha channel goes from 0.0 for fully transparent to 1.0 for fully opaque. We're starting the value at 0.0, and to make it become fully opaque, the final value needs to be 1.0. Finally, we can pass in the duration for the animation in seconds. Let's go with 1.0. Okay, now after fading in the blackout node, we want to reset the game. But just to make sure everything is working correctly so far, we'll skip that part for now and go ahead and fade the node back to transparent. To do so, we can first duplicate this entire line by holding down Shift and Control or Command and pressing D. And all we need to do is change the final argument to 0.0. Then let's give it a try. If we die and wait a couple seconds, the screen fades to black, then fades back in. Perfect. Okay, now for resetting the game, let's first create a new function by typing func reset_game with a return type of void. One thing we want to do to reset the game is set running to false. We also want to reset the score by setting score to 0 and setting scoreLabel.text to "0". And we want to show the start label by calling startLabel.show. Another thing we want to do is remove any pipe scene instances that currently exist in the game. To do this, we'll create another function called remove_pipes. So now let's create the function by typing func remove_pipes with the return type of void. And here we can loop through the pipe container's children by doing for pipes in pipecontainer.getChildren. Then inside the block, let's call pipes.queueFree. This will go through all the pipe container's child nodes, setting pipes to each one, then removing it from the game. Okay, now we also need to reset the player's position. To do so, let's save the script, then go to 2D mode. Now let's select the player's scene instance, and in the inspector, let's go to transform. For a starting position, something like 70 for X and 205 for Y should be good. Alright, so now let's go to the player script. Let's first create a constant for the starting position by typing const start_pause :vector2 equals vector2 70.0, 205.0. Next, in the ready function, let's do position equals start pause. Then for resetting the sprite, let's come down here and create a new function by typing func reset with a return type of void. And here, let's first set position to start pause. We also want to set both active to false and dead to false. And we want to make the sprite start moving to the right again by setting velocity.x to h speed. And one more thing we need to do is make the sprite's animation start playing again. To do so, we can call sprite.play. And because an animated sprite 2D can have multiple animations, we need to pass in the name of the animation as a string. So let's do . Alright, let's save the script, then go back to the main script. In the reset game function, we need to call player.reset. Finally, in the onGameOverTimer timeout function, we want to reset the game after the screen fades to black and before it fades back in. However, if we try simply calling reset game between the two tweenProperty calls, then run the game, die, and wait a couple seconds, we can see that it actually resets the game before the screen has a chance to fade to black. This happens because even though a tween by default waits until one of its animations finishes before starting another one, it has no control over code that isn't connected to the tween. So what we want to do is, instead of calling reset game directly here, we want to call tween.tweenCallback, passing in a reference to the reset game function. With this, after the first animation finishes, it will call reset game. Then it will start the second animation. And now if we run the game, score a point or two, then die, after the screen fades out, then back in, everything is back to the way it was at the beginning. Awesome. Okay, now really quick before we end this tutorial. If we stop the game and go into the debugger panel, we have a warning that says the parameter delta is never used in the process function. And it tells us that we can fix the issue by prefixing delta with an underscore. To do so, let's click the line, which takes us to the process function, and let's add an underscore in front of the delta parameter here. This simply lets Godot know that we're not using the parameter inside the function. And while we're at it, we're not using the ready function here at all, so we can get rid of the entire thing. And now if we run the game, we don't have any more warnings. And with that, we are done with Flappy Bird. We could definitely add some more stuff like music, sound effects, and a persistent high score, but we'll leave that for a later tutorial. Anyway, I hope you enjoyed this tutorial, and thanks for making it to the end. If you would like to see more tutorials like this, let me know in the comments. See you in the next one.